Picture the finest thoroughbred horse in the world. Fast, powerful, perfectly built. Now imagine someone tells you they can make it faster, not by replacing it, but by shaving every unnecessary ounce from its body, reshaping every curve that catches the wind, and rebuilding its lungs. You would doubt them. You would say that a machine already at its peak cannot be pushed further without falling apart. The engineers who built the Messerschmitt 109 thought the same thing in the summer of 1939. They were wrong, and the result of their mistake, a forced reckoning with physics, would produce arguably the most refined, most aerodynamically pure and most lethal version of the most produced fighter aircraft in history. To understand why the 109F was extraordinary, you first have to understand what came before it. The Messerschmitt Bayerische Flugzeugwerke 109, the Bf 109, had entered service with the German Luftwaffe in 1937. It was a revolution at the time. It had an enclosed cockpit, retractable undercarriage, and a powerful liquid-cooled engine that made it look like something from the future, compared to the biplanes that still filled many of Europe's air forces. Its early combat experience in Spain during the Civil War proved it was deadly. By the time Germany's air forces were tearing through Poland in September of 1939, the 109E, the Emil model, was the sharpest weapon in the Luftwaffe's hands. But the E model carried a hidden burden. Engineers at Messerschmitt knew it. The airframe had grown heavier with each successive version, loaded down with cannon, armour and increasingly powerful engines that demanded larger oil coolers and radiators. Those radiators hung beneath the wings like ungainly scoops, producing drag that bled away energy at every moment the aircraft was in the air. The supercharger inlet jutting from the left side of the engine cowling was angular and rough. The horizontal stabilizer was braced with external struts, each one dragging against the slipstream with the quiet persistence of friction. The tailwheel was fixed, dangling permanently beneath the fuselage. Every one of these details cost the aircraft speed, and speed was life. Willy Messerschmitt understood this. Yeah, so did Robert Lusser, one of the engineers deeply involved in the aircraft's development. They looked at the E model and saw not just a successful fighter, but a design that had been pushed to its practical limit in its current form. If the 109 was going to continue competing against whatever Britain, the Soviet Union and America were designing, it needed more than better engines. It needed to shed its skin and grow a new one. The result of their thinking would become the F model, the Friedrich. The development program was not a quiet, relaxed exercise in refinement. It was conducted under the pressures of a nation at war, with the Battle of Britain looming, and Luftwaffe commanders demanding performance improvements, while simultaneously demanding the production line not be interrupted. Messerschmitt's engineering team worked with an intensity that bordered on desperation. They knew the timeline was brutal. They also knew that compromise was not an option. Not here. Not with this aircraft. The first thing the engineers attacked was drag, the invisible enemy of every aircraft designer. Drag is the price you pay for moving through air, and in the late 1930s, aerodynamicists were learning just how many hidden sources of drag lurked on fighter airframes. Every gap, every protrusion, every rough surface added friction and pressure drag that stole velocity. On the E model, the radiators were large, rectangular, and mounted in a position that created enormous turbulence beneath the wing. The redesign for the F model changed this fundamentally. The new radiators were shallower and wider, recessed more deeply into the wing root area to reduce their frontal profile. The inner flaps of the radiator housings could now split apart to draw more airflow through when temperatures climbed under combat conditions, and this split system was automated, responding to coolant temperature without requiring the pilot to manage it manually. The engine was not overheating. The pilot was not distracted. The drag was reduced. 3 problems addressed with one redesigned system. The wings themselves underwent a transformation so comprehensive that they were, in practical engineering terms, entirely new structures. The E model's wings had squared off tips, a carryover from earlier design thinking. The F model received longer wings with elegantly rounded tips, a change that reduced the intensity of the vortices that spiral off wingtips and waste lift energy. Inside the wing, the structural bones were redesigned. The slats, which automatically extended to give additional lift at low speeds, were rebuilt with different actuating mechanisms. The flaps and ailerons were redesigned with improved hinge lines and surface shapes. If you had taken an E model wing and an F model wing and placed them side by side, apart from the general plan form, you would have struggled to find identical components. They were different machines wearing the same uniform. The engine cowling was reshaped with an obsessive attention to airflow. The supercharger intake on the F model was redesigned to present a smoother, more streamlined entry to the air coming over the nose. Compared to the blunter intake of the E model, this new geometry reduced turbulence and improved the efficiency with which the supercharger could compress the incoming air. A better fed supercharger meant more consistent power across a wider range of altitudes. The oil cooler system was also revised. Where the pilot of an E model had to monitor and adjust cooling manually in certain conditions, the F model's oil cooling was automated with a thermostatically regulated system. The cockpit workload decreased. The consistency of engine cooling improved. Then there was the tail section. On the E model, the horizontal stabilizer, the small wing-like surfaces at the rear that help control the aircraft's nose-up and nose-down attitude, were braced with external support struts. These struts were necessary on the E model because the tail structure was not strong enough to carry the aerodynamic loads without them. They were also, from a drag perspective, a punishment. The F model eliminated them entirely. The redesigned tail structure was strong enough to carry the loads unassisted, and the struts simply disappeared. The tailwheel, which had been fixed and permanently extended on earlier models, was made fully retractable on the F model. It tucked cleanly into the fuselage. Another source of drag eliminated. The rudder and vertical stabilizer were given a subtle but important asymmetry, with the left side of the vertical fin built slightly larger than the right. This sounds counterintuitive. Perfect symmetry is typically the goal in aircraft design, but the 109's propeller rotated in a direction that produced a natural tendency to yaw, to swing the nose sideways, particularly at low speeds and high power settings. This is a physics problem that every single-engine propeller aircraft deals with, called asymmetric blade effect combined with propeller torque. By building a slight asymmetry into the vertical stabilizer and rudder, the Messerschmitt engineers effectively preloaded the tail to cancel out this yawing tendency. The result was an aircraft that flew more cleanly straight ahead, demanded less corrective input from the pilot at critical moments like takeoff and landing approaches, and was therefore both safer and easier to handle. It was a subtle solution to a stubborn problem, and it worked. The combined effect of all these aerodynamic changes was staggering. The prototype F model was flown alongside an E7, which was itself an advanced version of the Emil series equipped with an upgraded engine, and the results shocked even those who had designed the changes. The F model was measurably faster than the E7 despite being powered by the same Daimler-Benz 601 engine in early testing configurations. Not a more powerful engine, the same engine. The drag reduction alone was adding velocity. When engineers calculated the numbers, they found the Friedrich's aerodynamic cleanup had effectively liberated performance that had been sitting in the E model's engine all along, wasted against the resistance of a rougher airframe. It was the aerodynamic equivalent of clearing a blocked drain. The water had always been there. Now it could actually flow. The production F model that reached Luftwaffe squadrons beginning in late 1940 introduced the new Daimler-Benz 601N engine in the F1 and F2 variants, and this power plant brought its own performance improvements separate from the airframe changes. With increased boost pressure and optimized fuel injection, the 601N could sustain higher power settings for longer periods. The fuel injection system was not a luxury feature, it was a tactical weapon. The Rolls-Royce Merlin engine powering the contemporary Hawker Hurricane and the Supermarine Spitfire Mark I and early Mark V used a float-type carburetor. In negative G maneuvers, when the aircraft pushed its nose down sharply, the float would briefly be starved of fuel, and the engine would cough, stutter, and sometimes momentarily cut out entirely. The Friedrich had no such weakness. In a diving maneuver, the Daimler-Benz kept running smoothly regardless of attitude, because its direct fuel injection fed the engine continuously, no matter which way gravity was pulling. German pilots learned this and exploited it deliberately. When pursued by a Spitfire, the German pilot would simply push forward hard, nose down and dive. The Spitfire pilot, if he tried to follow immediately, would watch his engine splutter. For a second or two the Merlin would cough. That was often enough for the Friedrich to gain separation. But the engine and the airframe were only two dimensions of the Friedrich's story. The armament arrangement was the third, and it sparked fierce debate inside the Luftwaffe that lingered long after the war ended. The E model had been armed with 4 guns in its primary configuration, 2 rifle-caliber 7.92mm machine guns in the nose and 2 20mm cannons in the wings. The wing cannons gave the Emil significant destructive power, capable of dismembering bombers and tearing through fighter airframes with a relatively brief burst. But wing-mounted cannons added weight to the wingtips, which was aerodynamically undesirable. And the feed mechanism for the wing cannon ammunition was complex and prone to jamming in the cold temperatures of high-altitude combat. The Friedrich simplified this. Its primary armament was 2 7.92mm machine guns in the cowling above the engine and a single Mauser MG 151 20mm cannon mounted in the valley between the engine cylinder banks, firing through the propeller spinner hub. This was called a motor cannon, Motorkanon in German. 3 weapons, centrally mounted, firing directly along the aircraft's thrust axis. The tactical advantages were significant. Centrally mounted weapons do not require harmonization, the process of angling wing guns so their streams of fire converge at a set distance. A Spitfire pilot with wing-mounted guns had to get the range right, had to ensure the enemy aircraft was at or near the harmonization distance for the crossing gun patterns to be effective. The Friedrich's motor cannon fired from the center of the propeller disc and hit precisely where the gunsight was pointing at virtually any range within reason. There was a directness to it that experienced pilots appreciated greatly. Furthermore, the MG 151 cannon had a higher muzzle velocity than the earlier MG FF cannon that had been used in the Emil's wings. Higher muzzle velocity meant a flatter trajectory, a longer effective range and a shorter flight time to the target. There was, however, a genuine weakness. 2 machine guns and 1 cannon added up to less total firepower than 4 weapons. Against heavily built Soviet aircraft operating on the Eastern Front, where German pilots began encountering the Ilyushin-II L-2 Sturmovik ground attack aircraft with its heavy armoured structure, the Friedrich's armament sometimes felt inadequate. The IL-2 was armoured so thoroughly that multiple 20mm hits were sometimes required to bring one down, and the Friedrich's single cannon, however accurate, was firing fewer shells per second than a twin-cannon arrangement. Some pilots requested field modifications, and the Luftwaffe eventually produced the F4 model, which introduced the MG 151 with the 20mm barrel rather than the 15mm version, improving lethality against armoured targets. Later still, underwing gondola packs carrying additional cannon could be added, though at a penalty in manoeuvrability. But in the skies that mattered most in the Friedrich's prime period, from late 1940 through the opening months of 1942, its armament was more than sufficient. Against wooden-framed aircraft, which included a significant portion of the Soviet Air Force's inventory in 1941, the 20mm Menengeschoss shell was particularly lethal. Menengeschoss translated roughly to mine shell, and the name was accurate. Unlike traditional solid-body projectiles, and the Menengeschoss was machined from thin steel tubing with a very large internal cavity, packed with a powerful explosive compound. Because the walls were thin and the shell was hollow, a single round contained far more explosive filler than conventional cannon shells of the same caliber. When it struck a wooden aircraft structure, the detonation did not merely puncture it, it destroyed the integrity of an entire section. The Friedrich arrived in Luftwaffe units at a moment of strategic inflection. The Battle of Britain had exposed the limits of the E-model at long range over England, where the fuel load restricted endurance and pilots found themselves fighting with one eye on the fuel gauge. The Friedrich's improved aerodynamics contributed marginally to range, and the drop tank capability was improved, but the fundamental problem of geography over the English Channel remained. Where the Friedrich truly flourished was in a different theatre entirely, one that opened in June of 1941. Operation Barbarossa, the German invasion of the Soviet Union, was the largest military operation in history. Along a front that eventually stretched for nearly 2,000 kilometres, thousands of aircraft on both sides began one of the greatest air wars ever fought. The Luftwaffe's fighter arm went east with the Friedrich as its primary weapon, and for the remainder of 1941 the results were devastating. Soviet pilots were brave and numerous, but often flying aircraft and using tactics that could not match the Friedrich's combination of speed, climb rate, and pilot training. In the opening weeks of Barbarossa, German fighter pilots were recording victory tallies that seemed impossible by Western standards. Werner Mölders, already an ace with experience from Spain and France and the Battle of Britain, became the first pilot in history to achieve 100 aerial victories. He was flying the Friedrich. Günter Rahl, who had finished the war as the third highest scoring ace of any nation with 275 victories, flew the Friedrich extensively during this period. The 109F became the tool through which an entire generation of Luftwaffe aces defined their careers. The aircraft's climb performance deserves particular emphasis because in fighter combat, the pilot who can convert speed into altitude and altitude back into speed most efficiently is the pilot who controls the engagement. The Friedrich's cleaned-up airframe, combined with the 601 engine's reliable power output at altitude, gave it a rate of climb that consistently troubled Allied opponents. Against the Spitfire Mark V, which was the principal British opponent in the Western theatre during this period, the Friedrich was generally considered superior in sustained climb angle and initial zoom climb. A Spitfire pilot who had been bounced from above by a Friedrich and tried to climb away and reset the engagement would frequently find the German fighter following him upward with uncomfortable persistence. The tactical implications of this were profound. If you cannot use altitude to disengage, you must turn. And the Friedrich, while slightly inferior to the Spitfire Mark V in sustained horizontal turning at medium and low altitudes, was not so inferior that an average pilot could consistently exploit the difference. Against the Hurricane, the Friedrich was in a different category entirely. The Hurricane Mark II was a capable aircraft against bombers and against less sophisticated opponents, but against the Friedrich it struggled. Its maximum speed was lower, its climb rate was lower, and its operational ceiling was lower. Hurricanes assigned to combat the Friedrich were operating at a structural disadvantage that raw pilot courage could only partially compensate for. Adolf Galland, one of the most decorated and analytically minded fighter commanders in the Luftwaffe, described the Friedrich as the peak of the 109 series. He had flown every version of the aircraft and had strong opinions about all of them. His assessment was not nostalgia, it was precision. Galland understood fighter aircraft the way a musician understands an instrument. He could feel what the airframe was doing, what it was costing, what it was giving, and his verdict was that the Friedrich represented a moment of perfect balance. Power against weight, firepower against aerodynamic cleanliness, pilot workload against aircraft capability. Beyond this point, he believed, every improvement in one dimension required a sacrifice in another. He was right, and history proved it. The G model, the Gustav, which began replacing the Friedrich in 1942, was powered by the Daimler-Benz 605, a larger engine that produced significantly more power. On paper, the Gustav should have been superior. In some respects it was, particularly at higher altitudes and against the increasingly powerful Allied aircraft, appearing by mid-1942. But the 605 was physically larger than the 601. Its installation required a bulge on each side of the nose cowling to accommodate the enlarged breech blocks of the cowling machine guns, which themselves had to be uprated to cope with the heavier high-speed slipstream. These bulges were not large, but they were not nothing. The Gustav's wing loading increased. The handling characteristics stiffened at high speed. Some pilots described the Gustav's ailerons as heavy and slow-responding in fast dives. The Friedrich had never had this criticism. In the Friedrich, the controls remained light and responsive throughout its speed range in a way that the Gustav, for all its raw power, could not fully match. The Friedrich was also the aircraft that carried the Luftwaffe through the most strategically decisive 6 months of the war. From the opening of Barbarossa in June of 1941 through to the late winter of 1941 to 1942, the Friedrich established air superiority over virtually every front on which it operated. The African theatre saw the Friedrich in the hands of Joachim Marseille, a young pilot of such extraordinary natural talent that even his opponents acknowledged his gifts with reluctant admiration. Marseille flew with an instinctive ability to position his Friedrich for deflection shots, firing at crossing angles rather than from directly behind, a technique that required exceptional spatial awareness and gun discipline. His accuracy was so precise that he routinely achieved kills with far fewer rounds than any standard gunnery manual would have suggested was possible. In one single day, in September of 1942, flying a Friedrich over the North African desert, Marseille was credited with 17 aerial victories, a record that remains among the most extraordinary single-day achievements in the history of aerial warfare. It is worth pausing on that number. 17 aircraft confirmed destroyed in a single day by a single pilot in a single aircraft. Whatever one thinks of the war and those who fought in it, the technical performance that made such a day even physically possible is a testament to what the Friedrich, at the peak of its development, could do in the hands of a pilot operating at the limits of human capability. The aircraft was not a passenger in that story. It was a partner. Its handling responsiveness, its engine reliability, its weapons accuracy, all of these contributed to making what Marseille achieved that day a product not just of his genius, but of his aircraft's excellence. By early 1942, the Friedrich's period of dominance was drawing to a close, not because the aircraft had failed, but because the war had caught up with it. The Supermarine Spitfire. Mark IX began entering service in mid-1942 with a two-stage supercharged Merlin engine that restored the performance edge the British had been struggling to maintain. The Yakovlev Yak-1 and Yak-7, Soviet fighters designed with some awareness of what the Germans were bringing to the Eastern Front, were becoming available in increasing numbers and at improving quality levels. American production lines were beginning to pour the Curtiss P-40 and eventually the Bell P-39 and Republic P-47 into Allied inventories, and while none of these were individually superior to the Friedrich in all parameters, the cumulative weight of Allied industrial production was shifting the balance. A Friedrich that had to fight 10 times a day against an opponent that could be replaced the next morning was fighting a different war than one fought in the autumn of 1941. The Gustav took over the main production line. The Friedrich's numbers gradually declined through attrition, and the factories shift in priorities. But among Luftwaffe veterans who flew both, the Friedrich retained a special place, not merely as an effective weapon, but as an honest machine. It asked no more of the pilot than it needed to ask. Its controls were not deceptive. Its engine was not capricious. When you pointed the Friedrich at a target and pressed the firing button, the motor cannon fired from the exact center of your gunsight with a precision that felt almost personal. It rewarded discipline and punished carelessness, which is everything you could ask of a fighter aircraft in the middle of a war that would not forgive mistakes. The 109 F4, the final primary production variant of the Friedrich series, introduced the uprated MG 151 with the 20mm barrel, the version that had been lacking against heavily armoured Soviet aircraft. This addressed the one meaningful criticism of the earlier Friedrich armament. With this final change, the Friedrich reached what its designers had always intended: the cleanest possible airframe, the best available engine of appropriate size, and the most accurate armament that could be mounted on the centerline. It was, in a precise technical sense, a complete solution, not an overcomplicated one, not a compromise squeezed by urgent demands, a complete solution. Willy Messerschmitt himself reportedly considered the Friedrich the version of his aircraft he was proudest of, not because it was the most powerful, but because it was the most elegant. Engineering elegance is not decoration. It is the quality of having solved a problem with exactly as much complexity as the problem required and no more. The E model had been a capable brawler. The G model would be a powerful heavy. But the Friedrich, for one bright period between late 1940 and early 1942, was a precision instrument that happened to be one of the finest fighting machines in the sky. That precision had consequences far beyond the aircraft itself. The lessons the Luftwaffe learned from operating the Friedrich, about the importance of aerodynamic cleanliness, about the tactical advantages of centrally mounted armament, about the value of automating pilot workload in critical systems like cooling, fed into every subsequent German fighter development program. There were engineers at Messerschmitt who spent the war years quietly studying the Friedrich's performance curves and comparing them against the Gustavs, noting exactly where the trade-offs had been made and what each additional kilogram of engine weight had cost in handling responsiveness at the margins of the flight envelope. Their conclusion was not that the Gustav was a bad aircraft. It was that the Friedrich had been a nearly perfect one. The Focke-Wulf 190, which arrived alongside the Gustav and complemented it on multiple fronts, drew on many of the same design principles even as it used a radically different radial engine. The engineers who watched the Friedrich's performance data come back from the front line understood what it meant. Weight is the enemy. Drag is the enemy. Automation that reduces pilot distraction is a force multiplier. These are not complicated ideas, but the Friedrich proved them with a clarity that data alone could never have provided. The 109F never became famous the way the Spitfire became famous. It was not a British icon. There were no propaganda posters with its profile stamped against a sunset, no schoolchildren collecting cards with its silhouette. It was a working machine in a brutal war, used and used up in thousands of engagements across a front that stretched from the Arctic to the Sahara. Most of those who flew it are long dead. The few surviving airworthy examples sit in museums, their engines silent, their control surfaces still, their paint schemes restored to a cosmetic approximation of how they might have looked when they were new and lethal, and everything depended on what they could do. But there is a truth about the Friedrich that does not require a museum to establish, and it does not require a veteran's testimony to confirm. The laws of physics are indifferent to propaganda and national loyalty, and the performance data recorded by both sides, in cockpit instrument readings and squadron debriefs and engineering assessments captured after the war, tells the same story from every angle. The truth is that for roughly 18 months it was the best production fighter aircraft in operational service anywhere in the world. Not the fastest in every condition, not the most heavily armed, not the longest ranged, but the best balanced, the most complete. The one in which the mathematics of aerodynamics, propulsion, armament, and pilot interface came together in a way that produced a fighting capability exceeding the sum of its parts. They doubted the redesign. They questioned whether stripping away the bracing struts, rounding the wingtips, recessing the radiators, and centralizing the armament would truly make a difference against opponents who were also improving. The answer came over the skies of Russia in the autumn of 1941, where a single generation of Luftwaffe aces wrote their names into the record books with a machine that was, briefly and brilliantly, without equal.